Hello, my dear students. Welcome back. So, in the last video, we have discussed about the type of redox reactions. There are 5 types are there. Out of the 5 types, we have discussed 3 types in the previous video. The remaining 2 types here we are going to discuss. So, that 5 types are: one is combination reactions, another one is displacement reactions, then decomposition reaction, then the fourth one is disproportionation reaction, and the fifth one is competitive electron displacement reactions. So the now fourth reaction is disproportionation, that is disproportionation reaction. The another name of this disproportionation reaction is auto-redox reaction. Auto-redox reaction. Right? So, actually what is happening here, for example, hydrogen peroxide, that is H2O2, it will decompose into H2O plus oxygen. Balance the equation, put 2 here, here also 2. Okay. Actually, disproportionation means in here that hydrogen peroxide is there. Here any one of the element, either hydrogen or oxygen. For example, here oxygen, that oxidation number is -1. You can check according to the oxidation rules. The oxidation number of oxygen is -1. You calculate here it is a separate molecule, so oxidation number must be 0, and in water the oxidation number is -2. Okay, so in hydrogen peroxide, oxygen oxidation number is -1, in water -2, oxygen 0. So what happened here, which is oxidation -1 to 0, that is oxidation, because the oxidation number is increased. Oxidation. Then you see here it is reduction. Why? The oxidation number is decreased from -1 to -2. So it is reduction. Clear? So the conclusion is the same compound in disproportionation reaction, the same compound can undergo both oxidation and reduction. Clear? So in such reactions, what happen? The oxidation state of here, the oxidation state of the same element is both increased and decreased. So this type of reaction is called disproportionation reaction. Clear? Now we will see one more example. That another example is chlorine plus potassium hydroxide KOH gives potassium chloride KCl plus potassium chloride KClO3 plus water. Okay. Now balance the equation, put 3 here, then put 6 here, then 5, now here 3. Now the equation is balanced. Now assign oxidation number for all the atoms and elements. Here this is 0, because it is a individual elemental, and here minus 1 will come, here this chlorine, here plus 5. So same element undergo oxidation and reduction. Which is oxidation? 0 to plus 5, this is oxidation. Then here oxidation number decreased, so it is reduction. Okay. So this is called disproportionation reaction or auto redox reaction. So now fourth type is completed. We will see one more type, that is competitive electron transfer reaction. Next, number 5, that is competitive. Fifth one is competitive electron transfer reaction. So in the previous video we have discussed about the metal displacement reactions. We studied one example, that is reaction between zinc and, this is zinc, and aqueous copper sulfate solution. The color of aqueous copper sulfate solution is blue. When a metal zinc is placed in an aqueous solution of copper sulfate, after some times when we observe, the intensity of the blue color will be slowly decreasing. That means it will be reduced, and finally it will be disappeared. So the reason is the zinc, it will be replacing copper from copper sulfate solution. So that means zinc atom releases electron. Zinc release electrons. Okay. So whenever, if any atom compare zinc and copper, zinc will immediately release electrons than copper. So zinc is highly reactive than copper. Okay. So reactivity of any atom depends on how it releases electrons. Okay. So that if any atom releases electron readily, that is highly reactive. If any atom releases electron very slowly, that is called less reactive. Clear? That is the concept. Here what is happening? Zinc is releasing electrons than copper, and it is replacing copper and forms zinc sulfate solution. So here zinc is highly reactive. Suppose if you are keeping, instead of this zinc, you are placing copper. This is zinc sulfate solution. This is copper, but the color is not changed. The color as it is, because it will not replace the zinc. Copper does not replace zinc. Okay. And take another example. Take silver nitrate solution in a beaker. This is silver nitrate AgNO3, and place copper. Here what is happening? This copper replacing zinc. Copper replacing this silver. Why? Because copper is more reactive than silver. Okay. So copper is highly reactive than silver. Okay, that is the concept. Now see the reaction. Copper plus silver nitrate AgNO3. This is aqueous and this is solid. So what will happen? You will get the product of copper nitrate CuNO3 twice. This is aqueous plus silver Ag. Okay. So now I think you hope you understood the concept. Here the copper is readily releasing electron than silver. So we are calling copper is highly reactive. Now check that which is oxidized and which is reduced. Assign oxidation number. Copper is 0. Here silver is 0. Here plus 2. And here actually this is plus 1. So before assigning oxidation number, balance the equation. Here to Ag. Okay. Now from copper to this copper, that is plus 2, this is oxidation, and here this is reduction. Okay. So from the above experimental observation, we can conclude that among the three metals, namely zinc, then copper, then silver, the electron releasing tendency, it is in the following order. This is zinc, copper, silver. So the electron releasing order is zinc greater than copper and greater than silver. Zinc, copper, silver. Clear? So this is called competitive electron transfer reaction. So which element or which atom releases electron at first? So it is called highly reactive atom. So this is called competitive electron transfer reaction. Okay students, hope you understood that all the types of redox reactions. So that's all about the types of reactions. So in the next video, we are going to discuss about balancing redox reaction. There are two types of balancing redox reactions are there. Okay students, thank you very much.